3.7, number 260. So we're supposed to sketch the graph of the inverse of this function as part A. So to graph the inverse of a function, the first thing to note is that the graph of f inverse is always the reflection of the graph of f about the y equals x line. So I'm going to superimpose on this graph y equals x. All right, that's the standard, I'd say diagonal line in the plane. So there's y equals x. So what I need to do is I need to reflect this graph about that line, and I'll have the graph of f inverse. Something that's helpful though is to get some guiding points to assist with that. So we also know that if it's true that f of a equals b, then f inverse of b equals a. In other words, you switch the coordinates. So for instance here, since I see that I have a y-intercept of -3 for the original function, right? 0, -3 is on the graph of f. So for f of x, we have 0, -3. It must mean that for f inverse, there's an x-intercept of -3, 0. Just reverse the coordinates there. So I know that f inverse should have -3, 0 on it. Also, you can play that with other points as well for all these problems. This is going to be a line, so I don't need so many. But the other thing that's useful is to always recognize that whenever the graph of f passes through the y equals x line, like here for instance, is the only place actually, that will be a point which is shared by the inverse as well. Okay? And that's because on this point, since it's on the y equals x line as well, that means the two coordinates are the same. So this is 3, 3. The two coordinates had to be the same because I'm on the y equals x line as well as being on the original function. So therefore, when I switch coordinates, I get the same thing back again. I get 3, 3. That's also on the inverse. So now that I've got these 2 points, and I know I'm supposed to reflect about y equals x, I can graph this fairly well. Maybe something like that. There's the graph of, there's f inverse. Okay, so we've got the graph of f inverse on the picture here, and now we're supposed to use part A, meaning our graph, to estimate f inverse derivative at 1. Okay, so I go to 1, and I go up to the inverse function, and then I look at what is the tangent line there, the slope of the tangent line there. Well, the slope of the tangent line is the same as the line itself. The slope's the same. So therefore, if I can just figure out the slope of the f inverse line, I'll know the slope of the tangent line there. Again, just because it's linear. The other problems are not quite as simple as this one in this estimation process at the end here. Either way, it looks like it's a slope of what? I got to go 2 to the right and 1 up. From my picture, that's the way it looks. Seems pretty reasonable. 2 to the right, 1 up, 2 to the right, 1 up. So I guess it's a half. Right? So delta y to delta x looks like a change of 1 to 2. So that's the slope at 1 as well for our line. And so that is our answer. We have a 1/2 slope for f inverse derivative at 1.